So let's talk about solving proportions. So don't forget, when we have a linear equation, somebody give me an example of a linear equation. Any example of a linear equation? X plus 2 equals 0. How would I solve that? I would use inverses. Subtract 2 from both sides, and I get x equals -2. Give me an example of a quadratic. Let's do something that I know can be factored. Plus 2x plus 4. If I factor that, it becomes x plus 2 times x plus 2. When I solve that, there are usually two solutions. So I have to set x plus 2 equal to 0, and that's really all I need to do because they're both x plus 2, correct? And x can equal -2. Oh look, that's the same answer, just by chance. Alright, so let me do one, and then actually I'm going to do both of these, and then I'm going to have you guys do one. So pencils down, let's just pay attention. Let's look at this first one. I'm going to move it down here so I can just work right alongside it. What is the LCM of this equation? X minus 6. Both of these quantities need to be in my LCM. So I need to, actually I'm going to move down just a little bit more. I need to multiply both sides of my equation by my LCM. When I do that, I get x plus 3 times x minus 6 on this side. We're multiplying here. And on this side, I do the same. What I do to one side, I have to do to the other. This is clearing the denominator, right? So if I do this, my x plus 3 goes away on this side, and my x minus 6 goes away on that side. So let's continue. What's left on this side of my equation? 8 times the quantity x minus 6. And what's left on this side of my equation? 2 times the quantity of x plus 3. Next, I would start doing what? Distributing. Does anybody see something I could do before I distribute? Does anybody see anything that these things have in common? Don't both of these equations on the outside where we're multiplying, you can't touch anything inside here because these are quantities, right? But don't I have a 2 in both of these? If you didn't realize that, it's okay because it would end up simplifying later anyway. But why not make our lives easier while I'm here? What does this become? A 4. All right, now let's continue. Let's distribute. 4x minus 24 equals x plus 3. A little easier to deal with, right? Okay, now what do I do with this? I've got x's here, I've got x's here, I've got constants on each side. Combine my terms. So let's move the x's. Where do you want to move? Let's move that one. It's smaller. What am I going to do with this? Do the inverse, which is add 24, and I end up with
3x equals 6.
If 3x is equal 27, what would 1x equal? 9. The only thing we need to be concerned about is what would be my excluded value? -3 positive 6. Does that affect us?
No.
No. We're done with that one. Number 2. Move this down a little bit. First of all, let's talk about the excluded values. What are the excluded values of these? And negative 2. What's my LCM? X plus 5, x plus 2. Excellent. What would I multiply this side by? Why? Vanessa, why would you say that? I already have an x plus 5, so couldn't I just do this? Cancel the x plus 5, because I already know it's right there, and multiply this side of my equation by x plus 2. Very good, Vanessa. Patrick. Both of these are my LCM, right? So I have to multiply both sides by x plus 5 times x plus 2, correct? Don't these cancel out anyway? So can't I look, let's do this side now. Can't I look up here and say, I need to multiply this side by everything up here? But these are going to cancel, so all I need to multiply by is, you don't have to do that, but it's a little easier, right? We don't have a denominator anymore. We cleared it. It's gone. That's why we did that. Okay, what's left over here? 12 times x plus 2, and what's over here? 4 times x plus 5. Anybody see it? The 4's can cancel, can't they? If I divide by both sides by 4, couldn't they just go away? What's left? 3x plus 6 equals x plus 5. Please don't let this part freak you out. I'm simply manipulating numbers. If not, you just distribute and you've just got more numbers to deal with, right? Just higher numbers. I just like my numbers to stay low. Okay, now what? Okay, so I'm going to get rid of this x, bring it over here, and get rid of this 6, and bring it over here. I'm left with 2x equals negative 1. When I divide both sides by 2, what will x equal? Negative 1 over 2. Questions on this so far? Yes, Armando. How come I subtracted x right here? On both sides? Because I was trying to move the x over here so I could solve. I can't solve anything if I've got x's on this side and x's on that side, right? Okay. Okay, so do this one and then put your answer in the clickers, please. Okay, so if you multiplied by the LCM, which is y plus 1 times y minus 3, you should have multiplied y plus 1 on this side and y minus 3 on this side, and you should have got an answer of negative 4. All right, let's do something a little bit harder. Again, just watch what I'm doing. What's my LCM of this one? Let me move this down. First of all, let's state our excluded values. What can n not be? Negative 1 or negative 7. What is my LCM? N plus 1, n plus 7. What would I multiply this side by after I cancel my n plus 1? N plus 7. And what would I multiply this side by after I cancel my n plus 7? N plus 1. Okay, so let's distribute. I've got n times n plus 7 on this side equals n plus 4 times n plus 1. What do I do with this mess right here? I can FOIL all those rainbows, or I think you guys see the box a lot easier. Let's do it down one right here. The box is just a way of foiling in a nice, neat, precise way. So if this is n plus 4, and this is n plus 1, what goes in here? N squared. And here? And here? And here. So it doesn't really take that much effort to just make sure you're right. Let's continue. So on this side of my equation I have what? N squared plus 7n. And on this side of my equation, what did I find in here? N squared combined, good job, plus 5n plus 4. I've got squares on this side, I've got squares on this side. What am I going to move? The squares. Well, look what happens. I've got 1 on each side, right? So can't I just take both of them off? Isn't that the same as saying subtract n squared, subtract n squared? That cancels both of them. What else do I need to do? Subtract 5n, subtract 5n. That's all I need to move, right? It leaves me with 2n equals 4. If 2n equals 4, what does 1n equal? 2. Go up and make sure that that's not an excluded value, and it's not, so we're good. Moving on. All right, let's move this down and find our LCM on this one. Do I have excluded values here? No, there's no variable in the denominator. There aren't any excluded values. So what's my LCM? 3 and 4. 3 times 4 to be exact, right? This side already has a 3, so what am I going to multiply this side by?
4.
And this side already has a 4,
3.
so what am I going to multiply by? 3. Distribute for me. What do I have left?
8x.
8x equals?
3x squared minus 3.
Good. Oh. Almost. Don't I have to distribute that 3 to everybody? 3x squared minus 3. What do I do with this? This looks like a quadratic to me. Move the 8x. Move the 8x to the other. I'm going to put it right here because it's going to squeeze right in between there. Why is it going to squeeze right in between there? Because it can. Because it should, right? Because that's where it belongs. If we put them in order of descent, it's x squared, then x, right? So if this side's going to be 0, and this side's going to be 3x squared minus 8x minus 3. Well, that's not fun. But I have a nice way of figuring these out. What's that? I'm going to use an X box. But when I use this X box, I'm going to fill in the box first. There's a very important reason why I'm going to fill in the box first, right? Because if I do the X first, you guys normally take whatever's here and put it here, and that's not true. What goes here? Patrick, why don't you finish this for me? What goes here?
This is FOIL.
No. Foiling this one is only a trial and error thing because you've got lots of different numbers here.
3x squared.
Okay. What goes here?
3.
Negative 3. What goes here?
9x
Negative 9x squared. And what goes here? Negative 8x. Awesome. What two numbers, when I multiply, I get negative 9x? See, this one you got to think about. Awesome. So this is negative 9x, and this is positive x. What goes out here? No. 3x. 3x times what makes 3x squared? X. And what goes here? Negative 3. And what goes here? 1. So, if I come down here and finish this off, it would be 0 equals what? 3x plus 1 times x minus 3. Now what do I do with this? Ryan, thank you for volunteering. What do I do with this now? How do I solve this? Set them both up to 0? You are correct. What does this one become? Good. This becomes 3x equals negative 1, and when I divide by both sides by 3, I get x equals negative 1/3, and this one is x equals 3. I don't have any excluded values, so I'm good. Now you guys do one.